Hello students, I am Dr. Sarika Pawar. Today we will discuss the machine learning problems and solutions. Students, we have earlier discussed the types of various machine learning algorithms like supervised machine learning algorithm, unsupervised machine learning algorithm and reinforcement learning. When we try to understand any topic using a problem and its solution, then we get it better. So we will start with some problems. Problem 1. Which of the following is not a type of supervised learning? See students, we have earlier seen that in supervised, what is the difference between supervised and unsupervised learning? In supervised learning, the labeled data set is used, and in unsupervised machine learning, unlabeled data set is used to group or cluster the data. So options are classification, regression, clustering, none of the above. We know that classification and regression are supervised machine learning problem and clustering is the unsupervised machine learning problem. So answer is clustering. Problem 2. As the amount of training data increases, four options are given. Training error usually decreases and generalization error usually increases. Training error decreases and generalization error decreases. Training error increases and generalization error decreases. Training error increases and generalization error usually increases. What should be the option? In machine learning, the data which we give to train the machine, to train the model is very important. And we have also seen that amount of data should be sufficient. If the data is not sufficient, it will be difficult for us to train and test, because whatever data we are available with, that we have to divide in the training set as well as testing set. Generally we start with 70-30. If we have 100 samples, then 70 we keep for training and 30 we keep for testing, reserved for testing. Okay, so whatever data we are available with, we have to divide it in training set as well as testing set. And if we are available with limited data, then it may be difficult for us to train the algorithm as well as to test the algorithm. What should be the option? Correct answer is training error usually decreases and generalization error usually increases. Okay, why? Because see, if we are available with the limited data set, then training error will increase, because the available data set we have to divide for train set and test set. Okay, so if limited data set, then train set will also be limited, and if train set is limited, then error will also more. Okay, so if we increase the training data, then training error will decrease and we will move towards the more accuracy, and generalization error will usually increase. Now next problem. This problem is based on the performance evaluation parameter which are used for the evaluation of machine learning algorithm. We have seen that if it is a regression problem, then we use mean squared error as a performance evaluation parameter. If it is a classification problem in supervised learning, then we use confusion matrix as a performance evaluation parameter. For suppose I have 10,000 emails in my mailbox, out of which 300 are spams. The spam detection system detects 150 mails as spams, out of which 50 are actually spams. What is the precision and recall of my spam detection system? We are using the Gmail, and in Gmail there is a machine learning algorithm is used to classify a particular mail in an inbox as a spam or not spam. That system we can call as spam detection system. Precision and recall, these are the two performance evaluation parameter which can be calculated from the confusion matrix. Suppose 10,000 emails are there in my mailbox, out of which 300 are actually spam, where there is a true class, that is the actual class, and vertically columns are the hypothesized class, that is predicted class. Hypothesized class you can call as predicted class. Okay, so what is the true class? There are only two classes, spams or not spams. A particular mail can be a spam mail or no spam mail. There is a spam detection system, and that spam detection system detects 150 mails as a spam, out of which 50 are actually spam. So 300 is a spam value of actual data, and out of this 300, spam detection system detects only 150 mail as a spam. 50 are actually spam. So now your task is to find the value of true positive, false negative and true negative. Now what is true positive? If actually it is positive and your predicted class detects it as a positive, then class S will be true positive. What is false negative? If true class, that is actual class of a output sample, is positive and your detection system detects it as a negative, then it will come under false negative. And if actual class of a sample is negative and your detection system is also detecting it as a negative, then it will come under true negative class. And what is precision? Precision is equal to true positive divided by true positive plus false positive, and recall is equal to true positive divided by true positive plus false negative. This is how we find. We will use the confusion matrix for solving this problem. Total mails in the mailbox are 10,000, and out of which 300 are actually spam. So we will write 300 value here in this row, blue colored highlighted row in front of spam, because actual spam are 300. Now out of this actual spam mail, the spam detection system predicts only 150 as a spam. Okay, so in this predicted column, gray colored column, we will write 150 as a predicted spam mails and 100 are not spam. So this spam detection system is correctly predicting 50 as a spam, and it is wrongly predicting 100 as a not spam out of total actual 150 spam mails. Out of total 150 spam mails, spam detection system is predicting 50 correctly and 100 it is wrongly predicting as a not spam. These 100 are also actually spam, but this system is predicting it as not spam. So that's why a TP, true positive value, is 50 and false positive value is 100. This false positive value is 100, and total 300 in 10,000 mails, 10,000 emails, 300 are actually spam. So not spam mails will be 250. So this 250 will be the false negative value. So if we solve this problem for finding precision and recall, so TP value we are getting 50 and precision is equal to TP divided by TP plus FP. FP is equal to 100. So TP 50 divided by 50 plus 100. So precision comes out to be 33 plus 33%. And recall is nothing but TP divided by TP plus Fn. You see this formula, TP divided by TP plus Fn. So it is 50 divided by 50 plus 250, it is 16.66%. So this is problem 4. Which of the following are not classification tasks? We know that in classification output is categorical in nature, and in regression problem output is continuous in nature. So out of these 4 options we will have to find an option wherein the output is categorical in nature. Okay, so finding the gender of a person by analyzing his writing style. Okay, so finding a gender of a person, it is categorical in nature because there can be only 2 output category, either male or female. So it is classification problem. Predicting a price of a house based on a floor area. Price of a house can be any continuous value like 1 lakh, 2 lakh, 3 lakh, 10 lakh, 1 crore, any continuous value it can take. So that is not a problem wherein the output is categorical. Now C is predict whether there will be abnormally heavy rainfall next year. So now we have to predict whether there will be heavy rainfall or not. So again there are two categories, abnormally heavy rainfall or no heavy rainfall. These are the only two categories. Okay, so that is also a problem wherein the output are categorical, discrete in nature. Then D is detect pneumonia from chest X-ray image. In this problem also, whether pneumonia is present or not, that should be detected by using the X-ray image. So that is also categorical problem because only two output categories are. Pneumonia is diagnosed, pneumonia is not diagnosed. Okay, so these are only two categories. So D is a classification task, C is also a classification task, and A is also a classification task, but B is a regression task. So correct answer is B, that is predict the price of house based on floor area. This is not categorical, so it is a regression task. It is not classification task. Now next is, which of the following is a categorical feature? Height of a person. Height can be 5 foot 1 inch. It can take any continuous value. It is not categorical. Price of a petroleum. It can be 100. It can be 101. It can be 103. It is also not categorical. Mother tongue of a person. It is categorical. Either it can be Hindi, English, any one language it can be out of 3-4 languages. So mother tongue is categorical. Amount of rainfall in a day, 100% rainfall, 90%, 10% rainfall, कितना भी हो सकता है. It is a continuous value. It is not categorical feature. So C is the correct option. Next problem. Which of the following task is not a suitable machine learning task? Finding the shortest path between a pair of nodes in a graph. Predicting if a stock price will rise or fall. Predicting the price of petroleum, grouping mails as a spam or non-spam. D, we have already seen that it is a machine learning task. Predicting the price of a petroleum, this can also be a machine learning task. Predicting if the stock price will rise or fall, it is also a machine learning task. But finding the shortest path between pair of nodes in a graph, it is not a machine learning task. Now in this case we have to find the options which are suitable for machine learning, and out of that, which is the whatever is the most unsuitable task we will select. Next problem. Which of the following is correct for reinforcement learning? Before that, now see what happens in reinforcement learning, how it is different than supervised and unsupervised learning, that we need to revise again. We have discussed it earlier. In reinforcement learning, the agent tries to learn a policy function, that is the base action to take at a given state. Okay, there is environment, there is agent, and agent takes some action continuously for the environment based on its current state, and the reward it is giving to the agent. That is nothing but the reinforcement learning. So the correct answer is B. The algorithm plans one action at each time step. C. RT plus 1. At a particular instant of time, RT, it is giving the reward. Then based on that reward, agent will take the action at that time instant only. So action taken AT at time instant T is based on the reward given at time instant T. And once the action is taken and it is implemented in the environment, based on that action and state of that environment, again in the next time state the reward will be updated. And in that R of T plus 1, based on that reward, action A T plus 1 will be taken. So this algorithm, reinforcement learning algorithm, plans one action at each time step. It cannot happen simultaneously. Next, problem 8. What is the use of validation dataset in machine learning? We have already seen that what is the use of validation dataset. The available dataset is divided into the training and testing dataset. And the testing dataset can also be further divided as a test dataset and validation dataset. Now, in validation dataset, during the testing, what happens? The model will tune all the parameters to get the maximum accuracy and minimum error. So validation dataset is basically used to train the hyperparameter of machine learning model to get the maximum accuracy and minimum error. And validation dataset provides unbiased evaluation of a model fit on the training dataset while tuning the model's hyperparameter. So correct answer is C. That's all for today, students. Thank you very much.